Hello everyone, welcome to the lecture series of Emporathum Numerical Challenge. Let's see the solution of the last question. So here the correct answer is order of n. It will take order of n time. So let's see how. Let's take the value of n as a to understand this, right? So now if I take I equals to 8, then for I equals to 0, the inner loop executes j equals to 0, j should be less than 8, that means 8 times. Then next, for next iteration, the value of I becomes 4. Value of j, it starts from 0 and j should be less than 4. It executes 4 times. For next iteration, the value of I becomes 2. J equals to 0. J should be less than 2. It executes 2 times. And for the last iteration, I equals to 1. J is 0. J should be less than 1. It executes 1 time. So basically, we can see, let's take the count of the iterations. This is our value of I and this is our inner loop work that start from j equals to 0 to I minus 1. Now for iteration 1, when we take the value of I as n, the inner loop executed n times, right? We take the value of n as 8, it executed 8 times. For second iteration, the value of I became n by 2. The inner loop also executed n by 2 times. For third iteration, it executed n by 4 times. For fourth iteration, it executed n by 8 times. And so on, it will continue if we take some other value of n. Let's say for some k value, it executed 1. So total work done over here is Tn is nothing but n by 2. That means the amount of work that is done by the inner loop will be the total time taken by this question. This is nothing but forming a GP, right? Now here for the geometric progression, the value of A is n, the value of common difference is 1 by 2 and we have to calculate k, that is number of terms in the GP. Now we can find out the number of terms in the GP using this. Just now we have seen that when we take the value of n as 8, then the inner loop executed 4 times. First it executed 8 times, then it executed 4 times, then it executed 2 times, and then it executed 1 time, right? So basically I value became 8, 4, 2 and 1 for n equals to 8. Now can I write this as log to 8 plus 1? So this is nothing, I executed basically, we have 4 terms in my geometric progression for taking the value of n as 8. Now if I write this as 8, log 2 will get cancelled. This will nothing but 3 plus 1, that is equals to 4 times, right? So similarly, when I take the value of n as 8, I have basically 4 terms. Similarly, I can write down that for some n value, the number of terms in my GP will be log 2n plus 1, that is the value of my k. Now we just have to substitute the values. The formula to calculate for geometric progression is rk minus 1 upon r minus 1. We know the values. A is n, r is 1 by 2, the value of k is log 2n plus 1, this is minus 1 and this is 1 by 2 minus 1. Now we can solve this. This is 1 by 2 log 2n plus 1 minus 1 upon 1 by 2 minus 1. Now we can take numerator and denominator, we can multiply by minus in order to make it positive value. So this becomes 1 minus 1 upon 2 log 2n and we can write this as 2 upon 1 minus 1 by 2. Now here this 2 log 2n, this 2 will get cancelled as this is the property of the logarithm that when the base of the logarithm is same as the base of the exponent, they cancel out each other. So here we will be only left with n. So this will become n 1 minus 2n and in the denominator I have 1 by 2. We can solve this. this is n 1 minus 2n upon 1 by 2. This will be 2n minus 1 upon 2n. They will cancel out each other. This is 2n minus 1, that is nothing but equal to order of n. So it will take order n time to find the complexity of one function. See you in the next video with the next Emporathum numerical challenge.